Today, we're breaking down the ultimate science fair trifold backboard. Whether you're a first-timer or looking to level up your presentation game, I'm going to walk you through every single section. Left panel, center panel, and right panel. So your project looks professional and catches the judge's attention. Let's get into it. All right, let's start with the left panel. This is your foundation. It sets up everything that follows. At the top of your left panel, you need your purpose or question. This is the driving force behind your entire experiment. So, what makes a good question? It needs to be specific, testable, and focused. Here are some examples. How does the temperature of water affect the growth rate of bean plants? Which brand of paper towel absorbs the most liquid? Does the color of light affect how fast plants grow? Notice how each of these asks something you can actually measure and test. That's the key. Avoid vague questions like, are plants cool? Or yes or no questions. You want it to be measurable and make it matter. Next up is your hypothesis. This is your educated guess, your prediction about what's going to happen based on research and logic. And here's the format you want to follow. If I do this, then this will happen because, and provide the scientific reasoning. Let me give you an example. If bean plants are watered with warm water at 25 degrees Celsius, then they will grow faster than plants watered with cold water at 5 degrees, because warm water is closer to the plant's optimal metabolic temperature. See how that works? You're not just guessing randomly. You're showing your scientific thinking. And here's the thing. Your hypothesis doesn't have to be correct. Science is about testing ideas. If you're wrong, that's totally fine. Just explain why in your conclusion. Below your hypothesis, you need research or background information. This is where you show judges that you actually understand the science behind your project. What should you include? Key scientific concepts, definitions of important terms, why this topic matters, and any previous studies or findings related to your experiment. Here's the important part. Don't just copy and paste from Wikipedia. Use credible sources, include specific facts, and keep it relevant to your experiment. 2 to 3 paragraphs is perfect. And don't forget, this panel needs visuals too. Include at least 1 or 2 diagrams, photos, or illustrations that support your background information. Label them clearly and add captions. Remember, your board should be about 40 to 50% text and 50 to 60% visuals and white space. Don't overcrowd it. Your section headers should be 36 to 42 point font, and your body text should be 18 to 22 point minimum. Everything needs to be readable from 3 feet away. Now, let's move to the center panel. This is your showstopper. The first thing people see is your project title, and it needs to make an impact. Your title should be huge. We're talking 72 to 96 point font, bold, and in a color that contrasts well with your background. It should take up about 15 to 20% of your panel height. What makes a great title? It needs to be clear, specific, and professional. Here are some examples. The effect of music on plant growth. Does temperature affect battery life? These tell you exactly what the project is about. Avoid vague titles like just plants or overly casual ones like my super amazing incredible experiment. Keep it between 8 and 12 words and use proper capitalization. Below your title, include your name in 36 to 48 point font, then your grade, school, and teacher's name in 24 to 30 point font. Make sure this information is centered and clearly visible. Next comes your materials list. This is a complete inventory of everything you used in your experiment, and I mean everything. Measuring tools, equipment, even the specific brands if they're relevant. Here's what a strong materials list looks like. 3 bean plants, same species, same age. Digital thermometer with plus or minus 0.1 degrees Celsius accuracy. 3 identical pots, 15 center diameter. 1 bag of brand X potting soil. 250 milliliter measuring cup. 30 centimeter metric ruler. See how specific that is? Quantities, specifications, measurements. Someone should be able to replicate your experiment exactly from this list. Below your materials is the procedure section. This is your step-by-step method, and it needs to be numbered and detailed. Let me give you an example of what a strong procedure looks like. Number 1, label 3 identical pots as plant A, plant B, and plant C. Number 2, fill each pot with 500 grams of potting soil. Number 3, plant 1 bean seed in each pot at a depth of 2 centimeters. Number 4, place all pots in the same location with equal sunlight exposure. Number 5, water plant A with 100 milliliters of water at 5 degrees Celsius daily at 8 a.m. And it continues like that. Notice the specifics? Times, amounts, temperatures. Everything is precise. Your procedure should have 8 to 15 steps typically, and each step should be one clear action. Here's a pro tip. Write in past tense because you've already done the experiment. And don't forget photos. Include 2 to 3 images showing your experimental setup or key steps in action. Make sure they're high quality, well lit, and have descriptive captions. All right, we're on the home stretch. The right panel. This is where all your hard work pays off. Let's start with results. Your results section is purely factual. This is what happened, not what it means yet. That comes later in the conclusion. Here's what you need. A summary statement of what you observed, data tables with all your measurements, graphs or charts showing trends, any qualitative observations, colors, textures, behaviors. Let's talk about data presentation. Your tables need clear titles, labeled columns with units and organized data. Here's a quick example. This has a label heading that says plant growth over 14 days. The headings for each column are day, plant A, plant B, and plant C. All of the data in the table is clearly laid out, organized, and labeled with the unit of measurement or the temperature. And every table needs a caption explaining what it shows. Don't forget that. Now for graphs. Choose the right type for your data. Line graphs for change over time, bar graphs for comparing categories, pie charts for parts of a whole, or scatter plots for relationships between variables. Make your graphs big, at least 4 inches by 4 inches, and use clear labels on every axis with units. Add a title and a legend if you're showing multiple data sets. Use colors that contrast well and are easy to distinguish. Now, here's the most important part, your conclusion. This is where you interpret what your data means. A strong conclusion has 6 parts. Part 1. Restate your question. The purpose of this experiment was to determine what water temperature affects the growth rate of bean plants. Part 2. Answer the question with data. The results showed that plants watered with room temperature water at 20 degrees Celsius grew the fastest, reaching an average height of 9.7 centimeters after 14 days. Part 3. Was your hypothesis supported? Be honest here. My hypothesis was partially supported. I predicted warm water would be best, but room temperature water produced the tallest plants. Part 4. Explain why with scientific reasoning. This occurred because plant cells function best at moderate temperatures. Cold water slowed metabolic processes, while hot water may have damaged root cells. Part 5. Acknowledge limitations. Limitations included small sample size, only 3 plants, and possible variations in sunlight exposure. Part 6. Real-world application. These findings could help farmers optimize plant growth by ensuring irrigation water is at appropriate temperatures. Your conclusion should be 3 to 5 paragraphs, not just 2 or 3 sentences. This is where you demonstrate your scientific thinking, so don't rush it. Finally, wrap up with future research or next steps. This shows judges you're thinking like a scientist and looking beyond just this one experiment. Give 3 to 5 specific ideas. Test a wider range of temperatures in 5-degree increments to find the optimal temperature, or increase sample size to 10 plants per temperature group for more reliable results. You may also investigate whether different plant species respond differently to water temperature. Make these suggestions specific and build on what you've learned. Address the limitations you mentioned and propose ways to improve the experiment. Before we wrap up, let's talk overall design. Here are your key rules. Color scheme. Pick 2 to 3 complementary colors and use them consistently. Dark text on light backgrounds for readability, or vice versa. Font consistency, use the same font family throughout. Sans serif fonts like Arial or Helvetica work great. Visual balance, mix text with images, graphs, and diagrams. Remember that 50 to 60% visuals rule. Flow. Viewers read left to center to right, top to bottom. Design with that in mind. White space. Don't cram everything in. Leave breathing room between sections. And standard size? Each side panel is typically 36 inches tall by 12 inches wide. the center panel can be 14 to 16 inches wide. And there you have it, the complete guide to creating an amazing science fair trifold backboard. Remember, left panel sets up your question and hypothesis, center panel shows your methods, and right panel delivers your results and conclusions. Take your time, be thorough, and make sure everything is readable from 3 feet away. If you follow this structure, you'll have a professional-looking board that impresses judges and clearly communicates your scientific work. Good luck with your science fair project. If you found this information helpful, click the like button. If you would like more information, leave me a comment to tell me what else you would like to know. As well, don't forget to review the previous video on the scientific method where it breaks each step down step by step in detail. That'll also really help you with your project. That's all for now. Until next time.